صل على محمد صل على
Okay, good morning, guys. Assalamu alaikum. Welcome back to Inspired Teens Grade 11 Mathematics, when today's lesson we'll be talking about application of trigonometry. Okay, so application of trigonometry starts off with these basic three rules, okay, that we have to know: sine rule, cos rule, and area rule. Now, the important thing when using these rules that we have to know is that we use these rules when we have non-90 degree triangles. Okay, so a non-90 degree triangle is, of course, a triangle that does not have a 90 degrees. A 90 degree triangle, okay, has a corner, an angle that is perfectly 90 degrees, obviously. Vertical and horizontal line would create a 90 degree angle. Okay, so in this case, right, you'll see we have a note on it later, but in 90 degree triangles, right, how we solve for sides and angles, if we have to call this A, we have to call this A, B, and C. In a 90 degree triangle, we use sine, cos, and tan, okay, where sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tangent is opposite over adjacent, sohka toa. So in 90 degree triangles, we can simply use sohka toa, okay, to calculate angles and sides, okay, provided that, of course, initially we have some values, some angles, or one side, one angle, whatever it is, but nevertheless, we can always rely on sohka toa in 90 degree triangle, okay, opposite of hypotenuse. You'll see, like, we're always involving the hypotenuse, right? And in order to have in order to have a hypotenuse in a triangle, you have to have a 90 degrees, because the hypotenuse is always opposite the 90 degree. So we can rely on sohka toa to work our way around a 90 degree triangle. Okay, but what happens when we don't have a 90 degree triangle? When we have non-90 degree triangles, that's where sine and cos rule comes in. Okay, so the sine rule, essentially, if we look at this little diagram, the angles we label with big letters. So this is angle A, angle B, and angle C, right? The sides we label with small letters, and we mimic the letter that's opposite the angle. So for example, here we have big A, the side opposite it would be small a. Here we have big B, the side opposite would be lowercase b. And here we have uppercase C, and the side opposite it would be lowercase c. Okay, so that's important to note. That's how we label it. Okay, and it's important to note for the formula as well, because the formula will be given as this: a small a over sine big A, small b over sine big B, and we need to understand what it means and like what it indicates essentially. Okay, and all it indicates is we are taking the sine. Okay, oh, by the way, you can even flip this over. It doesn't really make a huge difference as long as you flip both over. What I mean is you can write it as sine A over A and sine B over B. Okay, as long as you flip both, like you can't flip one and not flip the other. So if you want to write the angles on top and the sides at the bottom, that's perfectly fine also. Excuse me. Okay, so yes, that's what this indicates, right? So we are taking the sine of an angle. Okay, also sorry, we start off with the side, a side, any side. Okay, the length of that side, of course. Okay, and then we divide it by the sine of the angle opposite to that side. Again, we're taking the side over the sine, okay, the sine trig over the angle opposite to that side that we're working with, right? And by the way, if we move this guy a little bit over, okay, this is also equal to C over sine C. Okay, they're all equal to one another, but generally we work with two at a time. Okay, we work with two at a time because there'll only be like one variable or whatever, right? So you're not going to be working with all three at once, two at a time. Okay, so that's the sine rule, and that's how we should understand it. So irrespective of the letters, the understanding of sine rule we should have as the side divided by sine of the opposite angle. The side is equal to another side divided by sine of the opposite angle. That's how we should understand the sine rule. Okay, let's have a look at the cos rule. Okay, what about the cos rule? Okay, now the cos rule, okay, we're working with the same triangle, the exact same triangle, and the labeling is the exact same as sine rule. Okay, but now let's have a look at this, right? We have a squared is equal to b squared plus c squared minus 2bc cos a. So essentially what we're working with in cos rule, okay, the one that's left alone is this guy. One of the sides are left alone, or the subject of the formula. Okay, one of the sides are left alone, so a squared. This is the subject of the formula. Okay, obviously it has a squared, but we can easily get rid of that squared, right? Now we have b squared plus c squared. So you take the other two sides squared and you add them up. So you in the calculations, you work with the other two sides squared. Okay. And we subtract 2 times bc again. So we're still working with those other two sides. And multiplied by cos the angle in between those two sides that we're working with, or opposite to the one that's left alone. Okay, so that's how the cos rule works. All right, one of the sides, if this happens to be the side that's left alone, okay, or if it happens to be the side that's the subject of the formula, a squared, then on the other side of your equation, which ones are you going to be working with? Which sides? You're going to be working with the other two sides and the angle in between. Just keep that in mind. Okay, so why is it important? Because you're not always going to have nice letters like A and B and C. Okay, so let's just say if we wanted to have C as the subject of the formula, right? How would we do that? That's really simple. So what we do is we say C squared is equal to, now we, sorry. We should be working with that C because we're working with the side. Okay, so we say C squared is equal to, thereafter we work with our other two sides. So it's going to be A squared plus B squared minus 2, so that's just constant in the formula, minus 2 times those same two sides, so minus 2 times AB times cosine. Now, which cosine should we be working with? The one opposite the one opposite C, or the one that's in between A and B, which is now going to be C. It will match this. Okay, cool. Okay, so that's why it's important to understand the formula and not just memorize it or use the formula sheet. You have to understand how it works and which sides and angles are they actually talking about, so that you can do it irrespective of the lettering. Okay, now let's have a look at area rule. So before we discuss area rule, if we had to discuss area of a regular 90-degree triangle, okay, the area of a regular 90-degree triangle is simply half times the base times a perpendicular height. Okay, many people tend to forget that we're actually talking about a perpendicular height. So in order to utilize this formula that you know for years and years that you've been using, right, it actually only works with a perpendicular height. Okay, yes, in non-90 degree triangles, you can get a perpendicular height, but it's not ideal. In this 90-degree triangle, it's so easy to get a perpendicular height. For example, here I could use B as my base. I could say this is equal to half times B times my perpendicular height could be A, right? And you basically just work with the two sides that create the 90-degree angle. So A and B, they are the sides. 90 degrees is between these two sides. So you literally just work with those two sides in a 90-degree triangle for area specifically. Okay, so yes, in a non-90-degree triangle, that's how we'd get area. So let's see, how would we get area in a non-90-degree triangle? Of course, right, there's no 90 degrees, right, whatever this is. If we do have a perpendicular height, it's given like this, for instance. Okay, that is a perpendicular height. There's no perpendicular angle inside of this triangle, but we are given the length from the extreme base, the bottom of a triangle, to the apex, to the extreme top, and it's a perfectly vertical height. That's why 90-degree or perpendicular height. Okay, in that case, this could definitely be referred to as a perpendicular height, and you could use half times base times perpendicular height. Okay, just keep that in mind. However, of course, in these questions, we're not going to be given a perpendicular height. That's why we're going to be using the area rule. So what does the area rule say? It basically says we use half times A times B times sine C, and it's really simple. So we're going to say half times A times B times sine C. So we work with two sides and the angle in between. Two sides and the angle in between. So if we had C and A, we could also calculate the area of this triangle. We could say half, that's an eraser. We could say half times C times A times sine B, the angle in between. Okay, so just keep that in mind. Always the case when it comes to area rule. Half times two sides and then the angle in between. Okay, and sine rule, cos rule, area rule, these are for non-90-degree triangles. Okay, cool. So before we go through all of this, okay, we'll come back to those. I feel like it's better to go through afterwards. Here, I just want to go through this 90-degree. I told you it's in the notes somewhere. Maybe I'll use the top to keep it neat. But in 90-degree triangles, use sine, cos, and tan, or sohka toa. Always complete all angles and, okay, these are tips that we'll come back to all the tips after we do at least one question. But yeah, always complete all angles and sides in the triangle. Okay, that is true. And the example of that is simply if I have an angle like this, right? ABC, triangle ABC, okay? And I have theta, and I know that that's 90. Always complete it. So this here is going to be, remember, sum of angles in a triangle. All angles in a triangle add up to 180 degrees. So I could say 180 minus 90 minus theta. Okay, and then I get an answer of 90 minus theta. Okay, so that's what I mean when I say always complete all angles in the triangle as well as all sides if possible, right? So you always want to, irrespective of whether you have the value or not. So this is something that's very important for this section. Okay, many people might get confused in a section because a majority of the time your answers are not values. Okay, your answers are variables, and in this section that's perfectly fine because we're always expressing one thing in terms of another. Okay, or giving something, like I said, in terms of x, or expressing in terms of theta or whatever. So if you don't get a value, okay, you'll see there is like a particular question where they do give you values to substitute, and then they ask you for a value answer. Yes, in those questions, of course, but for majority of the questions, you're not getting answers. You're not getting values. Sorry, you're not getting values as your answers. You're getting variables, which is okay. Okay, so that's what I'm saying. In this case, you might say, oh, that's theta, that's 90. Why is there a need to fill out C when I don't even know what theta is? That's just because everything is expressed in terms of variables. So complete angles and sides in terms of variables. Okay, especially in a 90-degree triangle, always complete all sides and angles because it's really easy. You just use sine, cos, or tan. Like that's why you need to do it. Okay, so we'll come back to those rules now. Let's just go straight into a question. Okay, so question 7. A cameraman is stationed at the top of a vertical tower, okay, where TG is equal to H. Okay, so of course we're going to follow regular procedure. Everything that's in the question needs to be in the diagram. Now, in these sections, 2D/3D trig, the reason they call it that, I'm calling it application of trig, but maybe it's called 2D/3D trig, is because we are working with 2-dimensional or 3-dimensional diagrams, okay, and situations that they pose us in. So you have to really try your best to understand. You have to read the question. Understanding what's happening in the question is very important, okay? And of course, most of the time you'll see everything that's in the written is most likely going to be in the question, just because that's just how they structure these questions. They tend not to leave anything out, right? But of course, you're going to double check and make sure that everything that's in the written is definitely in the question. All right, so That being said, a camera person is stationed at the top of a vertical tower, okay, TG. So we need to understand, okay, TG, this is a vertical tower. And there's a little cameraman here, Casper the Ghost, okay, and they say TG is H. So TG is H, that's fine, that's labeled. So this is referred to as H, the height, okay. She films a cat starting at A, okay. So that's why what this line here represents, okay, is just her line of sight, the line of sight of the camera. The camera is looking at A. So a lot of the times they'll put you in the scenarios, these different types of whatever they're doing, and the lines just represent angles that were created when someone was looking. A lot of the time, sometimes there's a lighthouse example where someone is looking at a certain angle. So that's fine, right? They're just drawing in. So they're saying that she films a cat starting at A. So that's why this line represents the line of sight. She's looking at this cat, okay? Where the angle of depression of T after A is theta, okay? We'll go through angle of depression in a second, but we know that theta is in the diagram, so that's fine. The cameraman follows the cat as it walks. So the cat, of course, is not walking up, right? The cat is walking along the floor, essentially. And the question says the camera follows the cat as it walks in the same vertical plane, a distance x meters horizontal. So this in the same vertical plane is describing the camera, okay, meaning the camera hasn't moved up or down. The camera is still in the same vertical plane, okay, but it's just shifted now to look at it it's following the cat, and it says a distance of x meters horizontally to B. So the cat has walked horizontally to B, and the camera has essentially followed it. Okay, that's what it's saying. Okay, I hope that makes sense. So the cat walks to B. Initially, the camera is looking at the cat at A, but now the cat walks to B, so the camera follows it all the way to B. Okay, creating an angle beta, and beta is given in the diagram. So everything, every variable and angle and side that was given to us in the written is in the question, like it's in the diagram, right? So that's that's most likely what it's going to be. Let's talk about angle of depression, angle of inclination. Okay, so these are not too complicated. Okay, don't overcomplicate it. Angle of depression is simply if I have two horizontal lines, okay, and or not even, doesn't need to be a second one. The angle of depression is basically how far down, if you look at the arrow, right? The arrow indicates it to you well, even. Okay, angle of depression is basically a downward direction angle that creates a line. So for example, if I had to create a little line, okay, let's do something different. Sometimes they could give it, it's normally from a horizontal plane or a vertical plane, right? So the angle of depression could be this angle, could be given. How far down is this line compared to that line? Essentially, okay, so you're always looking for that. It's always a downward depression, that's why depression, right? A downward angle. And then angle of inclination is just the opposite, okay? So how far up, creating an incline, okay? This is creating a decline, right? So the angle of inclination creates an incline, okay, also from a horizontal. We could call this beta, for example, and that would be an angle of inclination, okay, always from the horizontal up to whatever line that it created, whatever angle it created. Okay, so angle of depression, of angle of inclination. Most of the time, it's like really not too important to understand, just because the diagram, the variables are most likely going to be given in the diagram. Okay, so that's that, right? Okay, so far we have this little shenanigan going on here. Okay, let's look at question 7.1. Determine B1 in terms of theta and beta. Now, what these type of questions, you need to be ready for anything, okay, which is maybe a bit unfortunate, but it is what it is. So of course, they're going to test you sine rule, cos rule, tan rule. Sorry, not tan rule, sine rule, cos rule, and perhaps area rule. Okay, you're going to be tested on those. However, okay, you need to be able to, you need to know your general like Euclidean rules, perhaps analytical rules, right? Basic things that they could add in here, even properties of a quadrilateral. Okay, don't be shy to revise those. I do have a copy of just like maybe some of you have, like from grade 8, even grade 8, grade 9, properties of basic quadrilaterals. Okay, I think, I don't know if I gave it to you guys or the grade 12s, but I'll put it in this document. All right, just because you'll see, like, sometimes they'll have a question that requires you to know a property of a rhombus, and they just assume that you know the properties of a rhombus. Okay, so just all those other things, just make sure you understand. And of course, Euclidean analytical, that comes from your Euclidean and analytical. Okay, so yeah, that being said, like I said, you're going to be tested on sine rule, cos rule, but you also expected to know other basic things they could add in here. Okay, namely things from analytical, Euclidean, most likely not analytical, but it's important to know as well, like distance formula and stuff like that, just in case you're given a Cartesian plane, right? It's not impossible. Okay, Euclidean, definitely. Okay, most likely not going to be hectic Euclidean, but like basic geometry stuff, right? As well as, what's the other thing I said? Okay, I forgot, but if I remember, I'll remind you. So let's have a look, right? So they said, determine B1 in terms of theta and beta. So they want us to determine B1. Here is B1. Okay. They want us to determine it in terms of theta and beta. Now, here is theta. It's the angle of depression. And this entire thing is the angle of depression, including theta and beta. Okay, and that creates the line TB. Okay, and beta essentially itself is just the line, is just the angle between the initial line of sight and the line of sight from T to B. So that's what beta is. Now, what you need to be able to see here is that we have a vertical line here. They tell us that, sorry, a horizontal line. They tell us that the cat walks a distance of X meters horizontally to B. So that confirms to us that this is a horizontal line. Okay, so we have horizontal plane here, horizontal plane here. All right, so these two are horizontal planes. It makes them parallel to one another. Okay, and since they're parallel to one another, or like we can try and use our fun angle. And in this case, B1 would be equal to, so here's the transversal. The transversal is what exactly? The transversal is a line that cuts through two parallel lines or touches two parallel lines. So that's the transversal. This is the first angle, B1, and it would be equal to this angle, the combination of this angle here. Okay, so again, that's just basic Euclidean geometry. You need to be on the lookout for these type of things, especially if they say express one angle in terms of another, or determine one angles in terms of certain variables. You're not limited to something specific. I'm not going to tell you that every single time this question, you're going to have to use alternate angles to solve it. No, that's just not how it is. Okay, but yeah. So determine B1 in terms of theta and beta. So because it's the entire thing, right? Because it's the entire thing, it would be theta plus beta. Let me just see. Okay. So 7.1. Okay. It's only 1 mark, so you're actually not required to give the reason. But the reason would be alt angles. Okay, and there's, oh yeah, we can, okay, there's no exact lines to label, so we don't have to mention the parallel lines, because T, what would we call that? Like T vertical line. I'm not gonna bother with that. So you don't have to give the reason either way. However, the reason would be alternate angles, and this line is parallel to that line. Okay, let's look at 7.2. Okay, so this way it gets nice and complicated. Show that X is equal to H sine beta divided by sine theta plus beta times sine theta. Okay, so yes, I know this looks very complicated, okay, but it's not that, it's the way to get this answer is not as complicated as it looks. It just has a bunch of variables. That's why it looks complicated. But to get this, right, you need to know something. these complicated things. There's definitely like either one of these things or a few of these things that were done. Properties of a 90-degree triangle were used. SOHCAHTOA. Okay. Properties of or the rule of cos rule or sine rule were used. Okay. And of course, any general geometry, possibly any general geometry, such as this, we had to initially do that, right? This is fun, parallel lines. Okay. But we're just going to assume that that's the easy part, right? But to get to this complicated answer, sine SOHCAHTOA, a 90-degree triangle was used. Cos or sine rule was used. Okay. Now, before we sort of look at this, right, there's many things you could use to help you or to guide you, right? But before we look at this, let's just look at the diagram and try and understand what is x, okay? And just understand how can we express x, okay? So in our diagram, here is x. X is the distance from A to B. Now, you'll notice in a lot of the triangle questions, okay, you will find yourself with a 90-degree triangle, okay? Remember, that's where SOHCAHTOA can be used, and a non-90-degree triangle as well. A lot of the time, right? Very extremely common. You will find yourself with a 90-degree triangle and a non-90-degree triangle, okay? Now, in the 90-degree triangle, you're going to use, most definitely, right? You don't be using sine and cos rule here. You're going to use SOHCAHTOA here. But here, you cannot use SOHCAHTOA. There's no 90-degree. You're either going to use your sine rule or your cos rule, right? One of the two. There's definitely no other option, okay? So, so essentially, yes, what we're going to do now, this question is a 5-mark question, is you are going to link these two triangles somehow, some way, because here you have x, right? So the thing that you want to express, x, the side that you want to express is in the non-90-degree triangle. So you're definitely going to be using a sine or a cos rule, okay? So let us look in. Okay, so that's the thing, right? And also, as you can see, right, we don't want definite values. In this section, if you can represent a side or an angle in terms of a variable, then you've solved for that side or angle, right? That's supposed to be what that side or angle is supposed to be represented by. Don't think like, okay, I haven't solved the value for this. I haven't proved that this line is 10, so I can't work with it. No, if you've proved that this line, for example, can be represented by sine theta times h, it's not, but I'm just saying an example, then you've proved for that side. That's perfect. You can use that for the next part of your question. Okay, so that's ideally what you want. You want to express sides and angles, okay, in terms of the variables given in the question, essentially. Okay, so let's get rid of this. Now, let's have a look at our non-90-degree triangle. So let's actually bring it back. Okay, let's look at our non-90-degree triangle and let's see what we have and what we can work with. So we have beta, right? And we have x. Okay, so remember, now you'll see we'll go through a few pointers. Maybe we can go through them now, actually. These are just a few pointers. They're not set in stone, right? They're not guaranteed that every single time they're going to give you a guaranteed answer of should I use sine rule or should I use cos rule. Ultimately, in my opinion, the best way to determine it is just through practice and seeing the trend, right? Just like having that understanding of, okay, I can see what I'm given, right? Understand that what sine rule is, right? Sine rule requires 2 sides and 2 angles, okay? Sine rule requires 2 sides and 2 angles, okay? And remember, one angle must be unknown or one side must be unknown. And then when it comes to cos rule, okay, remember we work with the angle, so the 2 sides and the angle in between and then the side opposite, right? Just really understanding that concept and trying to translate that understanding when doing a question, looking out for that, okay? But nevertheless, we can go through some rules that can certainly help, right? So no 2 angles, okay, essentially when you, so it's telling you a hint as to when you should use or even just try sine rule, right? If you know 2 angles and 1 side, you can find the other side/sides Okay, so of course it says here know two angles. If you know two angles, of course you have to know all three, because you can simply use sum of angles in a triangle to get the third. Okay, so if you know two angles and one side, you can find the other side. Now let's look at why this would not be cos rule. Okay, remember cos rule is a squared is equal to b squared plus c squared minus 2 times bc times cos a. Okay, so this says you know two angles. In this, you just have to know perhaps one angle. You know two angles and you know one side. Now, just say you know B. In cos rule, if you don't know at least two sides, you're not going to be able to work with it. Okay, hope that makes sense. So that's why that can't be cos rule. So that's a clear indication you should try sine rule. Okay, let me just explain that again. So this says here, if you know two angles and one side, you can try and find the other side slash sides. The reason I think side slash sides is because you're most likely only going to be solving for one side. But if you need to, you can solve for the other sides as well. Okay, so in this case here, right, you know two angles and one side. Why it wouldn't be cos rule is because in cos rule, to solve for cos rule, right, you'd at least need to have to know two sides. Okay. So two angles, one side doesn't really help with cos rule, so you could use sine rule there. Okay, then let's look at the next one. For sine rule, if you know two sides and an angle not between them, so now you know two sides. Okay, so we know B and C, right? So we know those as well, of course. And remember, A has to be the angle between B and C. But now just say we know angle C. That's not going to help us in cos rule because we actually needed to know angle A. So if you know, let's highlight this. If you know two sides and the angle not between them, that's another indication. It cannot be cos rule because you wouldn't be able to work with cos rule. You don't know enough. So you can use sine rule in that case. Now let's apply sine rule, okay, to this diagram. Let's just say we know two angles and one side. So let's just say we know two angles, theta, beta, and x. Okay, again, remember in this section, variables means you know that if you have a variable for the side or the angle, that means you know that side. You use that, right? That's like an answer. You treat it like a value. Okay, of course, like if you want to express AB as AB, that's different, right? I'm talking about having a separate variable X or something else that's not using the letters of the triangle. So now let's just go through when I have two angles in one side, how could I use sine rule? Remember, sine rule is side over sine angle, side over sine angle. So I'm going to use X over sine the angle opposite to it, sine beta. It's equal to, now I have to decide which angle, which side am I going to work with? I'm going to, because I have theta, I have to work with the side opposite theta, and that is AC. Now you'll see why I'm writing AC, okay, in a bit, okay? And of course, the angle opposite AC is sine theta. I actually only chose AC because I knew theta, and I wanted to work with the side opposite to theta, which is AC. So now in this case, this is like solved for, right? This is like known, that's like known, that's like known. It's not, the value is not known, but because we have them expressed in terms of our variables, it's like it's known. The only unknown here is actually AC. So in this case, utilizing this, we can leave AC alone. So we just have to take this over as multiplication. Okay, if you're confused by that for now, that's not what we worried about. So I'm just going to write it. So it actually becomes X sine theta over sine beta is equal to AC. Now you see you have this complicated weird thing, but all it took was the sine rule. Okay, so yeah, hope that makes sense. And that we basically got an expression for AC, and that's how they want us to work in these questions anyway. Find the expression for this and that. All right, let's quickly go through this one. If you know two sides and the angle not between them, so let's just say we know X and Y, and we don't know the angle in between it. We know perhaps this angle here. Sorry, this angle, we'll call it theta. Now, when we know two sides and the angle not in between, cos rule wouldn't work. So what can we do here? Same thing, right? I have this angle. I'm going to use that side. So Y over sine theta. is equal to. Now I need to consider a side and its angle opposite, essentially. So now x over sine, and the unknown here is technically angle C. Okay, so that's how we can utilize it. When we know two angles and two sides and one angle that is not between them. Now let's have a look at cos rule. Let's get rid of this, and that. Let's have a look at cos rule and hints as you can see, they like really good hints, right? Because this already rules out cos rule, so that's like definite as to when you can use sine rule, right? Cos rule. If you know two sides and the angle between, yes, then cos rule is possible. I'm not, so when I'm saying you don't have to use cos rule, it could be possible that you need to use sine rule for this one, because it would be possible knowing two sides and one angle. That could be sine rule, right? Remember, sine rule actually in general could be two sides, one angle, even though it depends which angle we have. You could either use sine or cos, but irrespective, you could always use sine if you have two sides, one angle, or two angles, one side, right? You're definitely going to be able to use sine rule. Okay, you're definitely going to be able to use sine rule. It's just like I said, it depends which angle you have and so on. But yeah, so no two sides and an angle in between. You can use cos rule or sine rule, right? It just depends. Like if the question, you'll see sometimes, like we'll go through this, right? So side opposite known angle. So what's in blue brackets, by the way, is what you can solve for. If you know these things, then you can solve for what's in brackets. So if you know two sides and the angle in between, you can solve for the side opposite to the known angle. What about also if you know two sides and the angle not between them, you can find third side. Let's see. That kind of confused me. Two sides and the angle not between them. So let's get rid of this and let's call this theta. And they are telling us you can find the third side. Okay. You can find the third side. So this is going to be yes. So you can actually work with this, right? So let's just say you know two sides. So it's a possibility to work with cos as well, right? So in this case, remember the one that's always going to be the subject of the formula, the side that's always going to be subject of the formula is going to be, let's relabel them so it's not confusing. Let's call this y, let's call this x. The side that's opposite the known angle, okay, is always going to be subject of the formula. So this is going to be y squared is equal to, now then we use the two sides that create the angle. So it's going to be AC and BC. So it's going to be x squared plus BC squared minus 2 times AB, so that's going to be x and BC multiplied by cos of theta. Okay, so yes, technically in this case, now our only unknown is BC. Okay, so you can solve it. It's going to be a bit complicated, but nevertheless, you can solve for that. Okay, so look out for that. But yeah, that's a really complicated example, to be honest, but it is possible. Okay, so it's telling you if you know two sides and an angle, you can use sine rule to find the third side. Right, so it just depends on the question. Do they want an expression for the third side? Then you're going to use cos rule, because if we compare these two, they're the same thing. Okay, but it depends what you want. Do you want to find the other angle? Use sine rule. Do you want to find the third side? Use cos rule. Okay, then let the last one, if you know all three sides, you can find an angle. Okay, actually you can find any of the angles depending on how you structure all three sides, right? And also another hint to use cos rule is if the question has a complicated surd. So when I say the question has a complicated surd, they want you to prove, let's just say they said show that x is equal to, if they didn't have this, they had x square root something cos whatever, right? That's what I mean. If the question has a complicated surd that they want you to prove that a certain length is equal to, that's generally okay, I need to use cos rule. Why I need to use cos rule? Because remember here, in order to solve for a, you actually end up have to square rooting both sides, right? So that's where the surd would come from, to leave that specific side alone. Okay, cool. Then we talk about, okay, we went a long time talking about the stuff, but okay, it's fine. Let's just talk about this. A bridge, what I like to refer to as the bridge. Okay, what is the bridge? It is basically a line that links two triangles always use the first triangle to find an expression for the bridge. Okay, so here's a few steps for the question that we were doing, right? Question has two or more triangles, generally one 90-degree triangle and one non-90-degree triangle. Your first step is to express the bridge using the first triangle, generally using the 90-degree triangle. So let's have a look at our question. Remember, a bridge is what links the 90-degree triangle to the non-90-degree triangle, basically what's common between the two. And here TB is actually the bridge. It's the line that's in the 90-degree triangle and the non-90-degree triangle. Okay, so that's the bridge. And it says usually express the bridge using the first triangle. Usually the 90-degree one is the first one. Okay, and that's exactly what we're going to do, right? We're going to express this guy using the 90-degree triangle. Let's see what they say next. Use the new expression of the bridge in the second non-90-degree triangle. This is normally where you would use sine cos rule. So let's do the first one, right? So before we get here, right, the steps to follow to get there is the steps that I wrote. Okay, we're going to usually use the 90-degree triangle to get an expression for the bridge. Okay, so let's try and get an expression for the bridge. Remember, we don't have to actually have values, we can just have variables. That's a-okay. Now in the 90-degree triangle, I have h and I have 90 and I want TB. Okay, I also have the newly solved for this here. This is important, right? That's why it's important to write out what you solve for. This is theta plus beta. Okay, P1 is theta plus beta. We solved for that in the previous question. All right, so that's, we write it down in the diagram. I preach that like a broken record. Okay, so always, again, you solve for it, you write it down, whatever's in the written, you write it in the question, everything you want in the diagram. Okay, so yes, so these are the things we have. Now ultimately in our expression, we're either going to use, this is it, in 90 degrees triangles, you're going to use sine, you're going to use cos, or you're going to use tan. Finish. You're going to either use sine, meaning you're going to say opposite, you're going to choose an angle, you're going to say opposite over adjacent, sorry, opposite over hypotenuse, or you're going to choose an angle, you're going to say adjacent over hypotenuse, or you're going to choose an angle, you're going to say opposite over adjacent. Now, it's actually easy to determine which one you should use. Go to the angle that you have. Now, when I say angle that you have, I'm not talking about anything, right? An angle in this section, it's very important. An angle that you have in terms of variables. I have that G is 90, but I don't care. I'm not going to use that, right? An angle that you have solved in terms of the variables of the question of the diagram, which is clearly B1. B1 is now theta plus beta, so I'm going to use this angle. So this is my angle B1. Now, the first thing I noticed that I know, I'm going to try and use what I know and express something, either sine, cos, or tan. So you'll see what I mean. I have B1. I also have H. And B1, H is opposite to B1. So I need to use one that has opposite, sine or tan, basically. Okay, so that's how you work with it. Okay, what do I have? What do I want? Essentially, what do you have? What do you want? That's how you use sine SOHCAHTOA in general. So I have that angle. Okay, I have H, which is opposite to that angle. So I need to have opposite in my equation. Now, that's what I have. What do I want? I want the bridge. TB. That's normally the first step. Express the bridge using the 90-degree triangle. TB. Again, we don't have a value for it, but that's what you want, right? And remember, always in your unknown, even if you're solving an equation for an unknown, it's perfectly fine to have x as an unknown, right? You don't have to have a value for it. That's what you're solving for. So it needs to be represented by a variable initially because it doesn't have a value. Same with this, right? TB is going to be represented as TB. So I have this angle, I have the opposite, and I want the hypotenuse. TB is the hypotenuse. So that is clearly telling me sine. Okay, so I'm going to say, depending, so you're going to say in triangle, sorry, just give me 1 second. Okay, so in triangle GTB, okay, I'm going to say sine, let me see, yeah, it's fine. in triangle GTB. Sine, you don't have to write sine B1 is equal to that side over that side. You can just directly substitute theta plus beta. Okay, sine theta plus beta is equal to, so obviously, okay, I'll write it for our sake, right? We're doing sine theta is equal to opposite. Okay, let's not use sine theta. Let's just say sine angle is equal to opposite over hypotenuse. And we know that it's going to be sine B1 is equal to TG GT over TB. Okay, so this one TG over TG over TB. Okay, we don't have to, again, you don't have to do this entire line. I'm just doing it so for reference. You can just directly go to that. So sine theta plus beta is going to be equal to the opposite. The opposite we had as H. Okay, and the hypotenuse is what we want to express now. Okay, we want an expression for the hypotenuse. Okay, so we have H, that angle, we want an expression for the hypotenuse. So what you have and what you want, all put in here. And now essentially what you want to do is you want to leave TB alone and have an expression for that bridge. The bridge is TB. Now, a little trick you can do is whenever you have a fraction equated to something, if your unknown is in the denominator, you can simply swap these two. Okay, and it works. Or you can take TB over as multiplication and then take this over as division and you'd get the same thing. Okay, so this becomes TB is equal to H over sine theta plus beta. Okay, sine theta plus beta. Now we completed step number 1. Express the bridge using the first triangle, generally using the 90-degree triangle. Okay, so that's done. We have an expression for the bridge. Remember, the bridge is TB, so obviously you have to identify your bridge. Okay, so now let's follow step number 2. Use this new expression of the bridge in the second non-90-degree triangle. This is normally where you would use sine/cos rule. Okay, so now we've completely ignored this guy. We're done with it. Okay, now we know we can even write it nicely and neatly if you'd want. TB is now H over, it's complicated, but it is what it is, sine theta plus beta. That's the expression for TB. That's what TB now is. Now we work with our non-90-degree triangle, okay, ABT. Now, in this non-90-degree triangle, we have two options, sine rule, cos rule. Now, let's assess what we have and what we don't have. We have an angle, we have a side, and we have a side. So we have two sides and one angle. No. Yes. Do we have anything else? Yes, okay, we technically do have more things, but there's a little step that we have to follow in order to get those more things. And that's this guy. I should actually write it for both, and I will do that. Always complete all angles and sides in a triangle, if possible. Okay, and that's exactly what we're going to do. We're going to use Euclidean geometry to complete the angles in this triangle. So right here, I can use angles on a straight line. Okay, and I can solve for B2. Okay, so there's two ways you could do this technically. Technically, you could use exterior angle of a triangle. You could use this that I'm going to do now. But essentially what this is going to be is 180 minus theta minus beta. Okay, because it's minus theta plus beta, so it becomes 180 minus, that's just angles on a straight line. 180 minus theta minus beta. Okay, and then we can even solve for A because third angle of a triangle, right? Sum of angles in a triangle. So all A is, so remember they always add up to 90. So A is going to be equal to 180 minus beta, right? Minus this guy. minus this entire bracket, 180 minus theta minus beta. Now, A is equal to, when you do the simplification, 180 cancel, theta and theta, beta and beta cancel, you're actually left with theta. So you solve for A as theta. Okay, now let's just say we didn't solve for that, right? We had two sides, one angle, two sides, one angle, two sides, one angle. Okay, so if I'll just go through this quickly, right? We need to end shortly because time is up. If we didn't solve for that, right? You may think, right? And I kind of made this mistake of telling you earlier. You may think that you know X, okay? So you may think you have two sides and one angle, but it's technically not the case simply because they want you to have an expression for X. So technically X has to be your unknown variable because they have it on the left-hand side. They have it as the subject of the formula. You can't really use this in your you can't really use that. This needs to be left alone. It's almost like it's represented by AB and you need to solve for it. Okay, but nevertheless, right, we do solve for it now. And essentially, we want to solve for X. So now we technically, let's not work with that. That's a bit ugly, but maybe we will have to, but let's see for now. We technically have one side and two angles. So one side, two angles, I'm pretty sure that's sine rule. Yeah, so one side, two angles. Okay, that is generally sine rule. Okay, generally speaking, that's sine rule. However, you can also use the answer as a guide. Okay, the answer has sine. The answer has majority sine. So this doesn't always indicate that you're going to use sine rule, but this is your first thing you're going to try, right? You're not going to look here and say, okay, I have 500 sine values here. Oh, let me use cos rule. No, that's not what you're going to do. You try sine rule first, okay? And see, that's why I say keyword try, because at the end of the day, sometimes you might follow all these guidelines and then in the question, there's like some weird exception, right? It's fine. You can also trial and error. I know time is an issue, but if the first one doesn't work, quickly try another one. Try using cos rule or try using sine rule differently or whatever it is. Okay, so now what we're going to do with sine rule, and I'm going to write it all here and we're going to end quickly. Okay, we maybe won't simplify it. You guys can simplify it. We'll continue next week. We'll do this question and complete the next question. Okay, so in this case, I'm going to use the sine rule. Okay, now in the sine rule, I need to have side over opposite angle. So I have to use the bridge. I created a whole expression for it. Okay, and ultimately I have to use X. Right, that's actually the only main thing you have to use, but you have to use X because you have to have X in your calculations because they want you to leave X alone. So H over, this is the side on its own, sine theta plus beta, all over the sine of the angle opposite to it, it's sine theta. Now this is equal to another side over its opposite angle, and I have to use X. I have to use X again because X needs to be in my calculations because it needs to be left as a subject of the formula. Now, how I'm going to leave X as a subject of the formula if I don't even have it in here? And the sine of its angle opposite is beta. So therefore, it's sine beta. Okay, so that's actually how we use sine rule, and we'll simplify it next time. Okay, and I'll rewrite it neatly and all. But yeah, you can attempt to finish this question. You can finish this question. You can go through the rest of the notes. But yeah, next week we'll be completing this. Okay, cool. So thank you guys so much for joining. We have ended this lesson for now. The session will be open for the next 10 minutes. If you guys do have any questions, feel free to unmute as well if you want to like unmute to ask a question. Okay, so yeah. Okay. Doesn't seem like anyone has any questions, so I'll just end it there and I want to start the next lesson either way. But yeah, thank you guys so much for joining. I hope that you guys have a good rest of your week at school, and I will see you guys next week. Jazakallah khair.